Yep. Hello, everyone again. Today we're going to walk through this Snowflake Terraform project. So what we're going to do, we're going to build some Snowflake infrastructure with Terraform, using Terraform. So quick overview, what is Terraform? So it's a tool, it's an infrastructure as a code tool. So you can define.
Can you remove this little window on top of this one?
Yeah, okay, got it. Yeah, this better. Yeah, thanks. So with Terraform, you can define and manage infrastructure using configuration files. You can define all resources and not only within Snowflake. You can use it with many other cloud services and providers like AWS, Azure, GCP. So it's not only for the Snowflake, and you can create any resources. Like in Snowflake, you can create databases, warehouses, roles, and so on. What we are going to create and to see how to do it. In AWS or Azure, you can create any other resources. I don't know, alerts in CloudWatch, Lambda functions, anything. So why? I think it's very important to mention that Terraform keeps track of what it manages using a state file. So in this state file, Terraform just record everything what was created, and that's how it can track all resources. And why teams use Terraform? Because you can create infrastructure in a repeatable way. So you don't need to click every time in UI and create databases. You can define it in Terraform files, and then just create it. Terraform creates these resources. Also, it's easier to track infrastructure changes in version control in GitHub or whatever. It might be GitLab or something else. And also avoid permission issues when, for example, developers can't create resources. Like, for example, I'm a data engineer. I have a developer role in Snowflake. I can create a database or warehouse. I can create it only using Terraform because Terraform has a user with specific role that allowed to create any resources like database or warehouse in Snowflake. And also, it's easier to apply same setup across the different environments, like dev environments, production environments. Yeah, so it's a very quick overview. If you want to, if you never worked with, just give me one moment. Yeah. If you've never worked with Terraform, I think it's worth to try this guide. So it's just Terraforming Snowflake guide. So it's very short, quick, and easy. How to build your first resources in Snowflake using Terraform. Just follow all these steps, all this in this guide, and you can create your first resources. For example, you can see here declaring resources. You have main.tf file, and you define in this file some resources. A resource, Snowflake database, a resource, Snowflake warehouse. So for the I think for the pet project, it's fine to have all resources in one file. Let's say it's main.tf file. If you have a bit bigger team, it might be different files. Like I worked on the project where we had different files for every type of resource. So for example, tf S3 bucket.tf, and in this file we defined all S3 buckets. Or I don't know, IAM roles .tf, and in this file we defined all IAM roles, AWS IAM roles. So this guide, this project, it's a bit more complicated because we're going to use YAML files in this folder config. And in this YAML file, we defined all our resources. So I think it's just better to start, and you can see how it works. Yeah. So first of all, as I mentioned before, Terraform has this state file to track all changes that has been applied. Yep. Yeah.
Yeah, I just want to make one step back for everyone who didn't work with Terraform, and just to give idea when you need it. So obviously, if we talk about data, and then it's only need that you kind of like build some kind of infrastructure. Initially, it was coming from public cloud, AWS, Azure, GCP. So to give you ability to build your infra using this like more or less human readable scripts, and you can store them as a traditional code in the repo. You have the pull request, you have deployment, everything. But then different vendors, they're starting to let using this kind of approach, and Terraform was the most popular because you can create all kinds of things in Snowflake using SQL, for example, by default, or you can trying to use SnowSQL CLI client. But assuming if organizations using infrastructure as a code approach, they might have Terraform for everything, and then it would be convenient for them to store using the same approach for the Snowflake. But the main idea, it's primary for the data engineers, or might be for database administrators, but I don't think we have these roles anymore. And they give you ability to avoid running the scripts in UI or clicking in UI Snowflake to create and drop resources. But it's a big set. It's infrastructure as a code. And it's very important part for data engineers. It's very important part for the managers. It's basically part of any system design, because you can explain how you're going to build something, but then you need to go kind of best practices. So infrastructure as a code, the most obvious thing to do, even without complications. So everyone should be able to do at least like little like task, spin up Terraform locally and create some resources in the cloud, or you can do the same in Snowflake. But yeah, that's the idea. Yeah. Okay.
Yeah, I have a question. How often, like on your experience, do you create new resources? Because like from my, it's just, for example, you're like building and creating like a data sets or databases in Snowflake or BigQuery. And in most cases, you don't often create a new one, right? At least like where I work. So what's your experience with this?
Yes. Applicable for Snowflake, I would say the power of Terraform is definitely not the Snowflake. It's overall infrastructure, or even overall your data infrastructure, because Snowflake is part of this. But you also will have definitely, for example, AWS, you might have some EC2, ECS, or maybe manage Airflow, S3 buckets, IAM roles, policy permissions. That's why more or less you need constantly do this. Especially the second, if you have more than one team member, you want to get track what's happening, right? And you have the option for code review. For Snowflake examples, I use the Terraform in 2 of my projects, but I'm there as a single data engineer. And I definitely not use as often as I want, because the biggest, you will create database very rare. But what you're gonna do with Terraform might do, you will create service users and users, these more or less often, but it has often challenges than you add the user, because especially service user, you need to create key pair, maybe with shell script, and you need to save it key pair, maybe in AWS secrets. It's like additional integrate how you're going to save the password. And the second, assuming there is new people joining, or we have some data shares, or I integrate new data sources, I need to change role-based access control, because we have the roles and permissions. And for any new integrations, I might need to create a role and permission. So roles and permissions, I change way more frequently, or adding user way more frequently than adding database. So adding database is you do it just once. Another benefit of this, if you have your environment as a code, assuming you have single Snowflake environment, and you work not at small setup, but a big organization, they want to have a development environment. Or you want to have some kind of stress test environment for very little time. So because you everything define as a code, you can click one button and change destination and deploy new Snowflake instance that will have all what you have. And you can have dedicated Snowflake instance. You can test, stress test, do any kind of QA, and then shut down it. So that's the use case. But overall, for Snowflake, you don't do this often.
Yeah.
That's it.
Yeah, got it. Yeah, thank you for explaining.
Yes, Sergey?
What about part of the disaster recovery plan? Is it better to have it then?
I don't think because by disaster recover, especially because we talk about AWS or Snowflake, it's kind of more or less managed services, right? If you like, I have like one of the recent lessons about cloud service models. So you have infrastructure as a service, platform as a service, and software as a service. So I think Snowflake, it's probably platform as a service still, because you're responsible for many things, and you don't need to do any failover recover in terms of infrastructure itself. You need to care about the data. Imagine, and I had this example, because of Terraform, I drop it trying to apply some permissions for the database, but it did in the way it wants to drop database, then recreate and apply, and drop my production database. This production database had data. I lost everything. It wasn't a big problem because I still have the data in the source. It just took time to reload. But what I lost, I used all my DDL tables that I didn't use Terraform or anything, because with Terraform, I only define database, roles, and permissions, and warehouses. Yeah, I tried to add users, then I dropped the idea with the users. Because I lost around like maybe 80 tables, I had DDLs for every table. And then for every table, I had this Snowflake store procedure, because I trigger Data Factory to like process and merge data. That was really painful. And I didn't have any backup. So it's basically, you might define it with Terraform and all your objects like DDLs and procedures, so basically SQL code. Or you can still have it as a SQL, but you need to have some kind of like backup of this. This is important.
Thank you.
Hey,
Yeah,
everyone. Can this Terraform be used with Microsoft Fabric? Currently, I'm working on one project.
You can just Google it, because Microsoft Fabric is the Azure thing. So
Yeah.
you can use alternative Azure Bicep. It's
Azure
100%
Bicep?
support. Yeah, it's basically the same idea, but it's built in for Azure. And they might have Terraform, but usually Terraform is behind, especially for Microsoft. It might have less features.
Got it. Azure-based Bicep. Okay.
Yeah.
I'll check. Thank you.
Yeah, so that can go.
Yeah, thank you. Yeah, so as I mentioned before, Terraform keeps track of what it managed using a state file. When you, so there are three, I think, basic commands in Terraform. Terraform init to initialize the project, Terraform plan to see what it's going to create, and Terraform apply to create. So when you run Terraform init, it initializes the project. If you run it on your local machine, it initializes the project and create the state file on your local machine. But here's the problem: how to share your state file with your teammates, for example. And the solution is to store state file in S3 bucket, for example. It might be anything else. It might be, for example, Azure, AWS storage, or something like this, blob storage. But I have access to, I have an account in AWS, so for me it's easier to create and to store a state file in S3 bucket. So first of all, we need to create, so we need to get key ID, access key ID, and secret key ID for this S3 bucket. In order to get these two variables, access key ID and secret access key, we need to create S3 bucket, create a policy, and allow to Terraform user to use this S3 bucket and create a user for Terraform. So let's quickly do this. So I have, I logged in my AWS. So I go to S3, click create bucket. Let's say Terraform project, something like this. All other options are default. Now we have S3 bucket. Then we go to the IAM, to the policies. So first of all, we need to create a new policy. Click create policy, click JSON, and you can just copy paste this from repo. So what it does, it allow to S3 get object, put object, delete object, and list bucket. And we need to adjust name of the bucket here. So it allows to bucket and to all folders inside this bucket. And that's all. Then click next, policy name, example Terraform, state, demo, and create policy. Now we have our custom policy and we need to create a new user. This is my old user, so let's create a new one. Terraform, for example. Next, we want to attach policy directly to this user. So let's find our new policy that we've created before, Terraform state demo. Next, create user. Now we created the user, attached the policy that now this user has access to S3 bucket that we created. This one, this new bucket. So let's go to this user, and you need to create access key. In this list, choose application running outside AWS. Next. You can skip it, just create. So now you need to copy the access key and secret access key. It's very important to copy it right now because later you can retrieve this one. So I just copy this. Done. Okay. Yeah. So we have our user and with access to this bucket. So when we run Terraform init, it will create a state file in this bucket. And yeah. Yes.
Oh, Aijan was the first.
I think she didn't lower.
Oh, okay. So for my question is not the question, suggestion, because you creating Snowflake Terraform resources, but did you create AWS resources with with Terraform, like this bucket, for example? And
No. Yeah, I know that. Yeah, you can create it.
yeah,
No,
yeah,
I didn't.
that's why basically you might have single repo and have two folders, AWS and Snowflake, and then you can like even you can still have single state, like where you store all like resources you build, but you can trigger each one individually. So ideally it would be, especially with vibe coding, like you can first create bucket, roles, policies, even maybe it's interestingly how you can create I am user with secret and password to make sure that your password will be saved in AWS Secret Manager. So this is again like best practice. I didn't do this. I just lazy about this, but maybe it will using a shell script to running this. But the idea it will store it all in is secret. This like ideal way. So and then you don't need to do anything like full automation.
Yeah, I agree.
Dima, you said you're gonna store those secret and I think you said key in the outputs or in the
you because by default, like if you're gonna do something like this is the command that Sebek will run manually, and it's have the key, but because usually in the organization you want to create something as a service users, that's why you can with couple more like steps in your code, you can save it into AWS secret. So it's not it doesn't matter will it save in your machine or not, but the idea it will store it in the secret manager.
How would you retrieve it from there to create then Snowflake?
That's another question. Depends where do you want to use. For example, if you're gonna use it in Airflow, right?
Oh.
Airflow connecting to AWS secrets with configurations, and it just like calling. This is how I'm using AWS Airflow. I just connected. Any Airflow will work, or any orchestration tool will work. Even DBT. No, DBT you're not able to pass secrets. You need, I think, copy paste. But for Airflow, you can use your backend secrets as a secret manager, and you just tell the name of your secret in AWS. And obviously, you need to have like permissions to retrieve it. In any or you just have lambdas or Python codes, whatever, for transformations. Again, you can reference the these connection details from secret manager safely.
Thank you.
Yeah. So the step 2 is we need to generate a Snowflake key pair. So it's a private and public key pair. And using this key pair, our Terraform can have access to Snowflake. So what we going to do? I have my terminal here, and I'm going to run this command. So this one to generate private key. Just hit enter and enter. So no passphrase. And next command, it's this command generates a public key. Yeah. So now we have public key, and you can see here. This file we don't need. So this is the private key. This is the public key. So the next step, we need to go to Snowflake and create our service account for Terraform, or service user. Grant some roles to this user. So what we did, I know that I think according to best practices, it's better to create some custom role and grant this custom role to Terraform user. But what we did on our project, we just created a service account, service user Terraform, and granted system roles, security admin and sysadmin to this user. Yeah, so we can, you have to be an account admin in Snowflake to create a new user. You see user Terraform user successfully created. Then you need to grant role security admin and sysadmin in order to this Terraform user can create databases, warehouses, operates everything, roles, and so on. And for the access, so there is a option or parameter or for each user in Snowflake, RSA public key. Each user has 2 public keys, can store 2 public keys. It's just for information. And we need to pass here our public key that we created before. So let me show you. So here is the public key that we created before. And we need to pass here only this part without begin and end. Yeah, okay. And we need to create a new warehouse. Since we have, for example,
I just want quickly about Snowflake. In the past, you can use login and password for anything, like for service user, for personal user. And that now Snowflake roll out new security requirements. First, for all, they added a new column that calls type. And I don't know, do you use this or not, but the type could be the legacy user, assuming it's user and password, but then type is a person. So every person user must have MFA or passkey. And the second, every service user should have this like key pair. It's just requirement. And I think soon Snowflake will completely shut down all like legacy users with user and password.
Yeah. Thank you.
Yeah,
I just want to show.
It's type person, but it should be type service, like line 4.
Yeah. Yes.
You basically
Yeah, I forgot to add some text here in types when
but it's very good interview topic, because assuming you're telling about Snowflake and they ask you, oh, what did you do? You say, we had many users, service, and it was the mess between service users and the person users. They missed the type. There are Snowflake security alerts about this. And I spent the time to make sure all service users connecting with key pair and all person users with MFA. This is a very simple story, but if you tell this hiring manager, it's awesome. Like, you just take care for everything.
Yeah, I agree. Yeah, I forgot to add this type to change it to service. Yeah, here you can see that RSA public key. So this is our public key, and it is connected to our private key that we're going to use with Terraform. Yeah. So regarding warehouse, by default, when you create your account, a new account in Snowflake, there are some warehouses. For example, this compute WH, you can use this one, but the owner of this warehouse is account admin. So what you can do, you can grant usage and operate on this warehouse to security admin and sysadmin, or I think it's better just to have a separate warehouse for Terraform. So it's up to you. So I'm creating a new warehouse specifically for the Terraform, and grant usage and operate on this warehouse. two roles, security admin and sysadmin. And since we granted these roles to Terraform user, so our Terraform user can operate this warehouse, demo compute. You can choose any name for this warehouse. And we can, yeah. So let's see what the next step. Next step, set up repository structure. So I have this repo and all this structure with all files. You see, you can just clone this repo. And what I'm going to do. Yeah, so you see, I cloned this repo. And yeah, so you see now I'm in this repo, main branch, and I will go through all these files a bit later to explain everything, like these roles, databases, warehouses, everything inside these files. Let me just finish everything, finish with this guide, and then with all details I can explain you about these files. So now you can open an IDE. It might be VS Code, or for example, I have Cursor. Yeah. So I have Cursor here. And we need to update some files here. So some configuration files. Let's just go from the beginning. Backends. So this is the file with configuration where we want to store our state file for Terraform. It says bucket and the name of the S3 bucket. So I think the name was like this. Key is the folder and the name of this file. So it will when I run Terraform init command, it creates in this bucket folder dev for dev environment, and this file snowflake infrastructure.tfstate. Here is the region, so adjust to your region, and encrypt you can set through. Same thing for production. So just adjust the name of the bucket, name of the folder. If you want, you can add here any other path. I don't know, developer, something like this. So just whatever you want. And region. Config will be the same. It's just it will be our next step to adjust the config, and I will explain later. In environments, so we have dev and production environments, and here project, it's just optional. So environment, dev or prod, maybe test, whatever you want. Region, so if you want to add a third environment, for example, test environment, you need to create a new file, test.tfvars, all the same, just adjust, for example, environment test. Adjust the region to the region where you have your S3 bucket. Snowflake role will be sysadmin, and Snowflake account and organization will be yours, and you need to run this command. I have it here. Where it is? Yeah, here. So find your Snowflake account and organization. You just run this command, and you can see your organization name, this, your account name, this. You need to copy paste here and here, update. according to your Snowflake account and organization. Snowflake user, this is the user that we created, this one, Terraform user. If you named it in, I don't know, Terraform, just Terraform or something else, please update here. So I don't need to change anything. You probably need. For production, same, just check everything in this configuration. Production, region, current parent roles, this will be the same. Sysadmin, adjust your Snowflake account and organization, and here you have a user. What else we need? We need to go to providers. And so this configuration, Terraform uses to connect to Snowflake. Yep. Yes.
I want just to highlight it's such a painful process to doing this because every version of Terraform provider, what version do you use now? Is it for Snowflake provider? Yeah, 2.1.
Yeah,
because for a very long time they have 0 something, then they switch to 1 something. Now it's 2 something. They change completely a lot of things. If your organization, big organizations running, like I was in Okta, they're running 0.7, they spend months to migrate to 0.9. And then because every new provider has like version, it has breaking changes. The challenge of this, yeah, Terraform doesn't care. Okay, it will change and apply things. But as I said in my example, if you did something wrong and you have many options, you can drop the database because it's then tries to apply the changes. Even simple example, you create database with DDL, you have it. And then you wants to import this database in Terraform because it's missing in state. But then you create in DDL, you have just 1 line of code, like create database. But database has a dozen different characteristics. And Terraform then create database. It has those characteristics different. And because they're different, it's not able to change it. It's go to recreate the database, and so it's very painful process. Yeah, just my comment about this. And in terms of cursor, is it cursor?
Yeah, this is cursor.
So can you go to settings?
Oh, sorry.
Yeah, I think okay, go to settings,
Cursor settings.
Yes, and I showed this before. You see where is indexing and docs? Yeah, so here what I'm doing is for this specific reason, because LLM going crazy about Snowflake Terraform because of many versions. And if you're using fresh provider, LLM trying to use code from old provider, it's going nuts every time. So I copy paste the link from Terraform documentation about Snowflake to here. It's indexing it, and then I do in prompt something. I say, hey, use this documentation.
Mm.
It less issues than it's doing this.
Mm-hmm. Okay. Yeah. Thank you. Good to know. Yeah. So in providers, you need to adjust only the name of the warehouse. We created demo compute, so it's demo compute. Nothing. I'm not going to change anything, and that's all for now. So we are on the main branch, and we adjusted these backend files, and we need to push these changes to main branch, and then we can start to create new resources. Updated S3. Just let me commit and push everything. Git push. Yeah. So I pushed everything. Let's check. Okay. Backend dev. You see my updated S3 bucket. Okay. So now we can. So this repo, how we create all resources in this repo. We use this YAML file, and we use GitHub Actions to create all new resources. So we let's say we want to create some new resources, databases, warehouse, roles, and so on. So we need to check out, git checkout, demo, 26, this date. Yeah, so we check out to the new branch, to our feature branch. And now we can create some new resources. We go to config. Let's start with databases. For example, we want to create a new database, which is called raw, for our ingestion tool, for Fivetran, for example. And so we can click, we can save. So you see databases. This is the name of all databases that will be created. Roles, R and RW, it means read and write. So here in permission file, you can see that for each role access, there is a different access for each role, R and RW. If you have only read access to database, you can only use database, schema, table, dynamic tables views, materialized views. So only select, only read. It might be, I don't know, analytics team, for example, who can only read tables in the database. For read and write role, we can fully operate. So create any new schema, operate, select, insert, update, and so on. So in this permission file, we don't need to change anything. Then we go to roles. Here are two types of roles: functional roles and account roles. So account role is just a repeat. It's just a repetition of built-in account role in Snowflake, sysadmin. So we need to uncomment this, sysadmin. And since we want to create a raw database, let's say that our role will be ingestion, and this role have access to database raw with access read and write. So we need this one. It might look a bit complicated. I will explain you later all details, and you understand why this raw, RW, and so on. In the warehouse, I think it's the most easiest. So you just uncomment this part. So the name of the warehouse, ingestion, and some configuration. After suspend after 60 seconds. I think in Snowflake this is the minimum. After suspend after 60 seconds. Max cluster count. You can also add size if you want. And roles for this warehouse. A role ingestion can have usage and operate access. So now we save this thing. We are in our feature branch, and we need to push these changes. Git add, git commit, edit new resources, git push. Yeah. Now we need to go to remote repo and set up GitHub secret that will store Snowflake private key to connect Terraform to Snowflake, AWS access key ID and secret access key to connect to S3 and store state file there. So you can go to the just let's create pull request. Create pull request. Okay. So let's go to the settings and create some secrets. secret, new repository secret, AWS access key ID. So you just need to copy your key ID, add secret. Okay. Then new secret will be a Snowflake private key. For the private key, what you need to do, you need to open your private key, for example, using any notepad, Sublime text or something else, and copy the entire text. Do you remember that for the public key, we didn't copy begin public key and end public key? For private key, you need to copy everything, including this begin private key and end private key. For security reason, just let me quickly create this secret on another screen. Yeah. And AWS secret access key. Yeah, now you see that I created Snowflake private key, AWS secret access key, AWS access key ID. So let me show. Example, you have private key, Snowflake private key. You just copy everything and paste it to the secret. Yeah. Okay. So now we have our secret, everything here. Yeah. So this is for GitHub. Oh, and also we need to create 2 environments in our repo. This is the dev and prod environment. So you go to settings again, environments, and create new environment. Type the name. So I already have this production and dev environment. So for production dev environment, why we need this? When our configuration file use environment to create environment-specific resources. For example, databases, warehouses, all the resources will have prefix dev underscore, prod underscore. And since we are going to use GitHub Actions, we need these environments in our repo, dev and prod. And later I will show you how we choose in which environment we want to deploy resources from this feature branch. It's nice to set some required reviewers for production environments, and I don't have anyone in this repo from my team, so yeah, I don't have this feature, but it's nice to have at least 1 or 2 reviewers, just for the code reviews and so on. That's best practice how to work with GitHub. And yeah, let me see that I didn't miss anything. Create workflow. Oh, create workflow files. So we already have this workflow files here. GitHub workflow, deploy, destroy, and plan. Plan. This is the Terraform plan command. Deploy. This is the Terraform apply command to deploy all your resources. Destroy. I don't think that you ever need this destroy workflow, but yeah, it just destroy, delete all resources that you have in Snowflake. Yeah, so you have all these files, workflow in the repo. You added GitHub secret. You created environment, and we added some new resources. Now we can run our workflow. So just go to the actions. Oh, sorry. Plan. And choose run workflow. Use workflow from. So we created in our main branch, we don't have any new resources. We created in our feature branch. So we choose our feature branch where we want to deploy it to dev or to prod environment. Choose dev. Rerun all grants. This flag false or true. It means that if you choose true, it reruns all grants. Grant access to all previous resources. For example, you already had a bunch of databases, warehouses, and so on, and you're going to create new role. Let's say, I don't know, data scientist. When you added this new role in your feature branch, and then you set this rerun all grants to true, and Terraform grant access to all previous resources, all existing resources to this data science according to the role that you defined in your configuration file. Yeah, definitely. But yeah. And this feature is just a very detailed log, and I've never used it, to be honest. So you then click run workflow, and we can see green, complete, everything. So you can click here and find plan Terraform. And this is the Terraform plan command. You can see run Terraform plan with some configuration, environment, blah, blah, blah. So where we store it, everything. And Terraform will perform the following actions. So it says that I'm going to create functional role ingestion, functional role, functional role raw underscore r raw underscore rw database raw sysadmin. It's custom role. Yeah. So this dev sysadmin ingestion raw and so on. So you can see the bunch of resources and plan 10 to add, 0 to change, 0 to destroy. This I like more. 0 to destroy. And so we can see that, okay, everything is good, nothing will be changed, nothing will be destroyed. Terraform just add some new resources. Let's deploy it and see how it goes. We choose feature to dev, false, off, run workflow. Yeah, you see initialize Terraform, so run Terraform init with backend configuration. It's our S3 bucket. Then Terraform FMT, so it's validate format of Terraform files. Terraform validate, configuration is valid, and plan Terraform apply failed. Okay, object does not exist. I think I missed something. In roles, ingestion. Oh yeah, I missed this one. Sysadmin and ingestion. Okay. Yeah, just let's rerun it. So while it's running, let me walk you through all these files. So we have here backend. This is the file that says that to Terraform store our backend in S3. And here is the configuration. Where exactly in S3? Grants, databases, locals. So the file with some local variables. We say that, for example, object prefix, this is the variable environment and variable project. Roles YAML, this is the decode our YAML. So take our, read our YAML file in config directory, YAML roles, permissions, and so on. So it stores, this locals stores some variables that we use in our other files. Oh, you see it's green, everything is good. So apply Terraform. It created our role. And we can check here. Warehouse. So we have our def ingestion warehouse. We have our Terraform user, new roles, def ingestion, def raw read, def raw read and write, def sysadmin. And we have new database, def raw. So why it's so complicated with everything? Let me walk you through. So as I said, this R and so read and write, it defines the access, so usage and only usage and only select, or you can use, modify, and so on. In roles here, we have functional roles, for example, analyst, developer, ingestion, transform, sysadmin. So we use, for example, transform role for DBT, DBT cloud, ingestion role for Fivetran, developer for data engineers who can only read raw because we don't need to change anything in raw. Only Fivetran writes data here. But we, as data engineers, we can read and write in bronze, silver, and gold layers. We can create schemas, tables, views, and so on. Analyst role. So since they are analysts, they need to build only dashboards. They don't need to create, update any tables in our layers. So they work only with a gold layer. So for gold, they have only read. This sysadmin, it's like a parent role for all other roles. So let's say you want to create a new user and grant access to all these roles. You don't need to grant like grant role this, grant role this. You just grant sysadmin role, and it just inherit all other roles that is includes here. We have here this account role. This is just same what Snowflake has, this built-in sysadmin role. Warehouses, yeah, if you want to add some new warehouses, you can just uncomment here. You can change the size of the warehouse and so on. For example, yeah, let's open this warehouse. You can define everything here in the file, like database. For example, you can define resource, Snowflake database, and name of this database. But if you have, I don't know, 10 databases, there will be 10 parts of this script in this file. It's not convenient to see everything and to maintain everything. So that's why here you can see Snowflake database, what it does. For each local databases, it depends on the role. So first of all, we need to have a role, and then we can create a database. And it creates the name of each database. For name, it chooses the object prefix and key, and comment, it might be any comment. So here we have locals. So we say for each local databases. So here we have locals, and in locals we define databases. For database and grants in our local database YAML. So let's open our locals. Database YAML. We have in database YAML in configuration dir. So this loop just goes through this YAML file and take all these names like raw, bronze, silver, gold, create a list of databases, and then grant roles according to what we describe here to these databases. Same thing with, for example, warehouse. You see resource Snowflake warehouse. So we say create Snowflake warehouse for each local warehouses. And here in locals, we define warehouses. For warehouses, specs in warehouses YAML. Warehouses YAML. Here, warehouses YAML. This is our YAML file with warehouses. Yeah, so it just goes through all this configuration, all this YAML, and create, create warehouse with all this configuration. If you want to change, for example, developers started to complain that they can use small warehouse. It takes too long to run DBT models. So what you can do here, you can just, let's say you've already created developer warehouse, you can change here small to medium, create feature branch, change size from small to medium, put your feature branch to remote repo, create pull request, and do the same. You can do the same, like again, run, plan, deploy, choose the environment, and that's all. You updated your warehouse. Yeah. So databases. Yeah, if you look through these files, databases and so on, especially if you ask, I don't know, maybe ChatGPT to explain line by line these files, you, I think you understand better. Yeah, I think that's all. If we have time, I can walk you through all these files. And for now, oh, one thing worth to mention. Dmitry said that it's nice to use DynamoDB. DynamoDB table.
It's the default settings for Terraform, right? You have DynamoDB and S3 for states.
I don't use DynamoDB. I just added some. Yeah, if you want to use DynamoDB, you need to create this DynamoDB table. This is just an example how to create it using AWS CLI. And then you need to add this configuration, like DynamoDB table, Terraform state log. This is the best practice because let's say that 2 engineers run the GitHub Actions with deploying Terraform resources at the same time. And in this case, they can corrupt the state file that we have in S3, and DynamoDB just prevent this corruption of the state file. In our projects, we didn't use DynamoDB because we didn't have a very large team, and just 2 or 3 people had admin access to the repo, and so they can manage which feature branch runs first or second, and so yeah, we didn't use it. But it's nice to have. You have a large team to add this configuration and to store everything. So you don't have this race condition.
Yeah, I think also want to mention. So you just saw example, like then Sobek show us how we can create a database and so on. One big benefit here first is the naming conventions. So if you define it in this repo, like, yeah, you can decide to redeem, but naming conventions remain the same. You won't get the situation someone will create, assuming I like to call my database like, for example, prefix of the company underscore something, like whatever, and the same roles. And this is one thing, but another, usually then you start, especially for many cases, then you start slowly just building your data warehouse and have a small team. You're doing everything in Snowflake UI, or you just grant everything to everything. But in some point of time, you might get request, okay, let's split the views between like gold layer analysts who can access on the gold layer view, and engineers, and maybe some external consultants work on your project. So you need to start give the granular access. And if you, before in UI, just granting everything to everyone, it will be almost impossible to do anything. So you basically need to start from scratch. But here, in this case, you first planning this, and you don't invent the bicycle. This is for 30 years is known things like, yeah, you have database, you have roles and policy, and for data team, you have analysts, engineers, maybe admins, something like this, and read, write. Yeah, that's why for the policy, you just avoid this nightmare with the policy. if you set up everything here.
Yeah, and regarding naming convention and so on. So I think, let me show you what we created. In databases, we have raw, and so what our database does, our database .tf does. So we join our, for the name of database, it join our object prefix variable with key. Key, this is the key. This is this one. Raw. This is the key. Bronze will be the key. Silver, gold will be the key. Our object prefix. This is the here. In locals TF, we have object prefix, and for the object prefix, we have here is the like if we have project, variable project, then join environment and project. We didn't define a project here, but you can add it. You can okay. You can uncomment this line project and add project. I don't know. Let's say like this. So when you create database raw, it will be def_surf_raw. If you don't want this, you can just do like this. So it basically just take the name of the environment, add underscore, and add it to each key in this YAML file. So def raw, def bronze, def silver, def gold. If we deploy to production, it will be prod raw, prod bronze, prod silver, prod gold. With compute, we have def ingestion. So warehouse, the same thing.
Oh, sorry, Sivek, I want to, while I not forget, one of the good practices, especially like in Snowflake, because you can have different compute warehouse for different teams. Then you mentioned in Terraform, it's very easy for you. For every service, you can spin up the new warehouse, for example, one for DBT, one for Sigma, one for analyst, one for engineers, one for the ETL, and so on. You can spin up it and control, and also automatically you spin up warehouse and the role. And also for roles, like you can just have by default admin role and you can like reader role. And when you have dedicated warehouses for every process, it will become for you very easy to track the cost, like how much DBT cost and how much, I don't know, Tableau, Sigma cost for you, and so on. And again, because of Terraform, you define the rules, and these functions you can just go and loop over to make sure everything has the right access.
Yes, it's thank you. You mentioned that when you create a database or warehouse, you grant also roles. If you create just a database, for example, a warehouse, so Terraform user will create it, and Terraform user will be the owner. So I don't know, you create a warehouse or database for developers, they don't have access because Terraform didn't grant it. So that's why we have here in our roles YAML roles like this main role, like it's a custom sysadmin role, but it's like a main role, and it includes our analyst, ingestion, developer, transform. You can add whatever you want, maybe data scientists or so on. And for each role, we define access to each database and what exactly access, read or read and write. So for warehouse, for example, name the same, join object prefix and key. We have key ingestion. Our object prefix is our environment. Def ingestion. If we run for production, it will be prod ingestion. And roles. I think roles is the most complicated. So you see this dev sysadmin. So this is this one, our role, dev sysadmin. It has ingestion. We can see dev sysadmin. Dev sysadmin has been granted one role, dev ingestion. If we add here analyst, developer, transform, and add all these roles, we will see that dev sysadmin has been granted 4 roles: analyst, ingestion, dev ingestion, dev analyst, dev developer, dev transform. Let's go to dev ingestion. Dev ingestion has been granted one role, dev raw, read and write. So you see here, dev ingestion, dev raw, read and write. And what our dev raw, read and write does, yeah, this is our this is the end role that we use for each resource: warehouse, database. Yeah, you see database raw, RW. So dev raw, read and write. So ingestion, our dev ingestion role has access with read and write to raw database. So it's in the name of the role, we define the access, read or read and write, and we define the name of the database. Yeah, I think that's all.
Yeah, this is amazing. I already create the in Figma cover for YouTube video. All good.
Yeah, thank you, Sebek.
No, it's actually covering really well in detail. So, and the good thing, it's actually the framework that you can, if you're building the Snowflake in your company, you can just apply it. Maybe change a couple parameters, but it works amazing. And yeah, it's not that complicated. It's a simple structure, but yeah, it has everything you need.
Yeah, when you read this file, like database, when I read it for the first time, I thought that it's too complicated. Like we define here locals, here's some loop for databases, grants, and so on. Because before I worked on the project where we just defined all resources in the file, like for example database, and we just you want to create new database, you just add new database. I don't know, CloudWatch alerts, for example, alerts.tf. You want to create new alert, you just add new alerts. But this approach is a bit different with these config YAML files. So yeah.
Yeah. Okay, then I think we're done. And everyone who is doing data engineering things, it's definitely worth to try, because you're doing Snowflake, all kinds of elements inside Snowflake. You're doing Terraform, that infrastructure is a code, and you can extend it to AWS resources. Yeah, and so then you can stop probably record and then send me the file. I will upload to YouTube. And now I'm doing a great thing for YouTube videos, because in the past I need to write time codes and everything. Now in Claude I have the rule. So from